Assalamualaikum warahmatullahi wabarakatuh, and good afternoon everyone. So today we will have chapter 3 part 2. Okay, uh, for our last class, okay, in part 1 you have learned about converting, okay, decimal, binary, decimal, and other bases. Okay, and for today you will learn about additional operation on binary. Okay, um, for this part, okay, you will learn about sign magnitudes, one complement and then two complement. Okay, this topic part 2, okay, can be defined as short. uh, Okay, this is the content for today's class, and as you can see that we will start with binary integer representation. Okay, because before we go more further, okay, on next content, okay, what is integer? Okay, integer is whole number, okay, number bulat, and it is not fractional number. Okay, when it is whole number, okay, number bulat, of course it is not fractional number. And integer can be negative, zero, and positive number. Okay, and for example, integer, okay, we have -5, 1, and so on. Okay, positive, okay, positive we have 97, 99, and so on. Okay, not integer, integer. Okay, for example, okay, what I can give you, maybe -1.43. Okay, maybe what else, square root of 2. Okay, and so on. So the most important thing here, you need to know that integer, what is meant by integer. Okay, after you understand about the integer, okay, you will introduce by what we call as the sign magnitude. Okay, in this sign magnitude subchapter, okay, actually it is about negative and positive number. Okay, how can we represent negative and positive in computing? Okay, then when we want to do additional operation, add, okay, or plus, okay, to represent the negative, okay, number, okay, we need to use what we call as the one complement. Why? Because in sign magnitude method there are problems, okay, on the negative. Okay, and then we have one complement. Okay, after that, okay, in one complement there are also problems, okay, in one complement. So we have two complement to solve one complement. Okay, so this is our contents, okay, for today. Okay, this is our objective for today's class. Okay, the first objective here is you should be able to identify, okay, identify the weakness of binary representation of integers. Okay, you will see about this later. Okay, and then the second objective, you should be able to utilize, okay, utilize or use sign magnitude technique to represent data. Okay, how can we represent, okay, especially negative data, okay, negative digit for, okay, and then you should be able to utilize one complement technique, okay, to represent data, okay, because we have problem in sign magnitude. then we have one complement. Then okay, as I mentioned before, we also have in one complement, so we need to learn what we call as the two complement technique. Okay, so this is our objective for today. Okay, so binary integer representation. Okay, how computer represent binary. Okay, especially integer binary. Okay, computer represent integer in binary. Okay, what is binary? Binary is 0 and 1. Okay, the combination of 0 and 1. Okay, how to differentiate between positive and negative. Okay, as I mentioned before, positive and negative number. Okay, in the world of computing or computer. Okay, how we use what we call as first sign magnitude, one complement, and also two complements. Okay, we will go one by one on this technique. Okay, don't worry about this. Okay, we go to our first technique. Okay, that called as sign magnitude. Okay, you will know why we call it as the sign magnitude. Okay, as info that you need to know that our computers, okay, our powerful computers in the world, okay, cannot understand positive negative. Okay, so how to solve this? Because in the world of calculation, okay, we have negative and positive, right? So how the researcher, okay, or scientists, okay, for the computer, okay, solve this problem. Okay, they first use 1 and 0. Okay, use 1 and 0 to represent negative or positive number, or accurately integer. Okay, in TERGER. Okay, we have spelling problem here. Okay, integer. Okay, so as you know, okay, as you know also that computer system use 8 bits. Okay, so this is not correct right now. Okay, for example, right now our Windows use 64 bits. Okay, before this we have 32 bits. Okay, but okay, we use 8 bits for education purpose. Okay, because if you want to use for 64 bits, so we have totally our bit here will be 64 bits. Okay, so it's better, okay, if we use 8 bits instead of 64 or 32 bits. Okay, so we will see more information about sign magnitude, okay, after this. Okay, so what is sign magnitude technique? Okay, sign magnitude technique use leftmost. What is leftmost? Paling kiri. Okay, bit represents a single bit where 0, okay, 0 positive, 0 for positive. Okay, and 1 to represent negative. Okay, so you need to remember this. Okay, two things. Okay, 0 represent positive, 1 represent negative, and this is not apply to all bits, but most leftmost. Okay, what this mean by leftmost? If you have 0 1 0 1 here, for example, so it is our leftmost. Okay, if you have 0 1 0 1, then we have 0 1 0 1. So the leftmost here is here. Okay, so you need to make sure that what is mean by leftmost. Okay, we have an example here. Okay, so for the positive, if you see here, okay, there we use 0. Okay, and then negative, use 1. Okay, it is similar with this second example. Okay, positive 0. Okay, and negative will be 1. Okay, so easy concept. Okay, easy concept. If you want to represent negative, use 1 at the leftmost. Okay, so do you think that it is a good for having this leftmost to represent negative and positive? Okay, so next slide. Okay, we'll explain you everything about this. Okay, as you can see here, there are two disadvantages, okay, of the sign magnitude. Okay, two disadvantages. Okay, the first disadvantages, when we use sign magnitude, we actually reduce the value that can be represented by the bits by half. Okay, we will see this example later. Okay, we keep this first. Okay, next, okay, we have another explanation about it. However, okay, the total number can be represented are still same. Okay, this also, okay, I will show you through example. Okay, maybe you cannot see about this, okay, at this moment. Okay, but I believe that you will understand about this statement after you see the example. Okay, just on our next slide. Okay, and another disadvantages, okay, this sign magnitude cause error in arithmetic operation. Okay, we have error. Okay, that's why, as you can see at the beginning of our content here, we have one complement, we have two complements. Okay, and this is to solve the arithmetic error that happen when you use sign magnitude. Okay, stay tuned. Okay, but after this I will explain about these disadvantages through example. Okay. Okay, to understand about the disadvantages that I just mentioned before, okay, we refer to 4-bit data representation. Okay, not need to have 8-bit, 32, 64 bits right now. Okay, when you see, wait, you can see here, okay, without sign. Okay, that means that we didn't use the sign magnitude. What can we have? Okay, the value that we can see can use, okay, is between 0 to 15. Okay, how can we get this? Okay, so we can have 0 0 0 0 0 0 0 1 0 0 1 0 until 1 1 1 1. So the total number here, okay, is 16. Okay, if you can believe, if you cannot believe this, you can just list down all the bit that possible here. Okay, what is mean by value here? Okay, value means value of here is starting from 0, right? 0 0 0 0, and then we have 15. Okay, at the last value. Okay, so we have range 0 to 15. Okay, so we have what we call as the 16 bits. Okay, number of bits here. Okay, 2 power of 4 here. Okay, we can say this is 16 bits. Okay, because we can have 16. Okay, with sign. Okay, that's mean with sign means when we have this. Okay, so what happened? Okay, right now, okay, we have number. Okay, 1 bit. Okay, here used for negative or positive. So what can we have right now? Okay, actually we have 0 0 0. Okay, 0 0 0 1 0 1 0, and the total number here is 7. Okay, we just have 7 here. Okay, when we have sign, okay, that means we have negative for signs, and we also have, okay, 0 0 0, okay, 0 0 1. Okay, another 7. Okay, 7 for plus 7 for positive number. Okay, so with sign, if you can see that, okay, the value that can possible to us to represent the bit is only 7. Okay, compared to without bit sign. Okay, the total value here is until 16. Okay, actually this the total here is 8. Okay, the total number possible is 8, right? Okay, 8. Okay, okay, because we have 0 to 7. Okay, 8 possible. Okay, so as you can see, this explain about total number can be represent still same. Okay, but the value, okay, if you can see here, value. Okay, value here 0 to 15, that have 16 possible value, and here we have only 8 possible value. Okay, so I hope this will make you clear about what is meant by the statement that we have here. Okay, this statement. Okay, reduce the value that can be represented by bits by half. Okay, by half mean, okay, we have is remember 7 0 to 7. Okay, 0 by half. Okay, before this, without sign, we have 0 to 0 to 15. That contain uh, 16. Okay, possible value. Okay, for this one only 8 possible value. Okay, we'll see about the another disadvantages. Okay, about the error. Okay, after this. Okay, and before that, we have another example. Okay, this time we focus on when we have 8 bits. Okay, when we have 8 bits, okay, without sign, okay, for positive negative, we have here 2 5 6 possible value. Okay, however, when you use one of the bit, okay, left most as our sign, so we have value between 0 to 1 to 8, 1 to 7. That's we have 1 to 8. Okay, if you can see, half from 2 5 6 will be 1 to 8. Okay, and you can also see that the range still same. Okay, we have 2 5 6. Okay, so I hope this will clear. Okay, give you more clear, because we have 2 example. to explain about the problem of the sign magnitude techniques. Okay, this slide will explain about the second disadvantages of sign magnitude techniques. Okay, from here, okay, you will see error in arithmetic operation. Okay, and before we proceed with this, make sure that you can convert. Okay, can convert in this case, in this part 2, decimal to binary, binary to decimal. Okay, you also can use your scientific calculator to convert this. Okay, we have a manual way. Okay, so for me, I will use this. Okay, I use table. Okay, we have 1 2 3 4 bit first, and then we have another 4 1 2 3 4. Oh, where is my pen? Nothing happen here. I cannot write down here. Okay. Okay, so as you know, okay, when we have here this 0 2 0 2 1 2 2 2 3 2 4 2 5 2 6 2 6 2 7 4 5 6, this is 6 2 7. Okay, so we have total 1 2 4 8 16 32 64, and then we have 1 to 8. Okay, why we need to have this table? Okay, this will help you to convert, okay, from binary to decimal, and decimal to binary. Okay, so you also can use your way. Okay, and the most easiest way by using your calculator. Okay, back to our example here. Okay, so what is the result of 1101 0011 plus 01101101? Okay, so from here, okay, you need to make sure that this is in we need to make sure that the leftmost here, okay, the leftmost here is represent the sign. Okay, so we have 1 here, that's mean we have negative. Okay, then followed by the binary here, we have 0 1 101 0 0 1 1. So you just total up the place that have 1 0 here, and here, you will get that we have 83. Okay, and then the second one, this symbol is positive. Okay, positive, you replace with this number before 83. Okay, if you have here 1 1 0 1 1 0 1, okay, you will see that 1 2 1. Okay, so what happened right now? Okay, what happened right now? Okay, it is actually, okay, positive 109. Okay, just make sure you correct it. Okay, firstly, and then we do the operation. Okay, we have 1 plus 1 equal to, don't say it is 2. Okay, we are working on binary, so this is 1 0. Okay, 1 0, we put 0 here, and then we we carry 1. Okay, then we have 1 here, another 0 1, so we have 1. Okay, 1 1 0, carry 1. Okay, then 1 1 0 1 1 1 0 1 1 1 0 1. Okay, and then from here, okay, 1 1. Okay, and then from here we have 0, we have 1. Okay, we have 1. Okay, and then if you can see here, okay, we have 1. Okay, so because we have symbol 1 here, that's mean we have negative. Okay, and if you put here, okay, 1 0 0 0 means by 64. Okay, 64. So this is not correct, or we can say that this is wrong answer. Okay, wrong answer. Okay, so that's why it is said that the disadvantages of sign magnitude that we have error, okay, in arithmetic, because of, okay, that I see here 1 here representing negative. Okay, and the total, okay, answer here is also wrong. Okay, wrong answer. Okay, so how can we solve this? Okay, how can we solve this? Okay, we can solve this problem through the uses of one complement. Okay, one complement. Okay, so we look at another example. Okay, to make you clear about the problem of sign magnitude. Okay, this is our second example on error in arithmetic in sign magnitude. Okay, actually what we want to do, okay, we have this. If we convert here, okay, it's 1 1 3. Okay, plus with, okay, because 1 here, so this is negative 64. Okay, the correct answer should be 48. Okay, 48. So we look at in binary perspective. Okay, so we just copy paste, okay, our number in binary. Okay, then we just need to calculate this. Okay, so we have 1 and 1. This will be 0 1. Then we just have here, okay, 0 0, and then we have 0 0 0 0 0 0, and then we have 1 this. Okay, then we have 1 0 1 1 1 is become 0 1, so 1 1. Okay, so as you can see here, okay, okay, we have 1 here, that's mean, okay, that's mean we have negative. Okay, and if you convert this, okay, I give you shortcut, okay, before you will get it is 15. Okay, so this is also give wrong answer because of this sign. Okay, so that is why we need to solve this problem. Okay, we have question here how to solve this problem. Okay, we solve it through what we call as the one complement. Okay, one complement. Okay, we will discuss about one complement, okay, further on our next slide. Okay, what is one complement? Okay, one complement, each of negative binary number is performed simply by changing every 0 to 1 and every 1 to 0. Okay, this is also known as the invention. Okay, so every 0 to 1, 1 to 0. Okay, and for example, okay, in this technique, one complement, if we have 2 Okay, 2 in 8 bit will be 0000010. Okay, and to represent 2 to negative 2, okay, we convert. Okay, each of 0 here, okay, become 1. 1 becomes 0. We know in theory how can we represent negative number by using one complement. Okay, so we look at this question. Okay, we have question calculate 20, okay, plus negative 10 using one complement method. Okay, how can we solve it? First and all, we need to change every decimal number that we have into binary. Okay, this is up to you. Okay, to use whatever technique that you want to use. Okay, this is not wrong. Okay, if you just use your calculator to get the binary. Okay, change all number into binary. Okay, but in this example, okay, they just use 6 bits instead of 8 bits. Okay, for me I will stick with the 8 bits. Okay, that's okay because the left digit, okay, we not use the last digit, the left digit. Okay, so what happened right now? Okay, when we convert 20, it's become 0 1 0 1 0 0. Okay, when it is 10, okay, we have actually 1 0 1 0. Okay, then as you can see here, okay, we need to change 1 0 1 0, okay, it is 10 into first complement. First complement, how? Every one in every 0 to 1 1 2 0. Okay, so we have from 0 0, okay, 1 1, right? From 1 becomes 0, from 0 1 1 0 0 1. Okay, so this number represent the first complement. Okay, after we get the first complement, okay, after we get the first complement, we do the additional calculation. Okay, so what we have right now, okay, we have just do it. Okay, we have 0 and 1 is become 1. 0 0 0, 1 1 becomes 0 and carry 1. Okay, then 1, then 1 0, carry 1, and then we have 1 0. Okay, if you can see here, we have 1 in front. Okay, what we do, okay, what we do right now, okay, we need to add this 1 into our answer here. Okay, so what we have right now, 0 0 1 0 0 1 plus with 1. Okay, so we have here 1 0 0 1 0 0. Okay, so what can you say here? Okay, 0 1 0 1 is equal to 10 base 10. Okay, so by using first complement, we get the right answer. Okay, so I hope you can understand about this. Okay, as what we have in sign magnitude, okay, actually one complement also have its own disadvantages. Okay, what is the disadvantages? Okay, we have problem representing 0. Okay, why? Okay, when 8 is 0, we need to do 1 complement 1 1 1 1 1. Okay, as you can see here, when this is 1 1 1 1, this will cause what we call as the overflow. Okay, overflow, not flow. Overflow in certain arithmetic calculation. Okay, we will see about this later, okay, in our example. Okay, don't worry about that. Okay, we have question here, which is to show the overflow issues. Okay, so we have 64 plus 65. Okay, in real math we have 64 plus 65, which is the answer will be 1 to 9. Okay, so we try to show in binary. Okay, in binary we have 64, so this is 0 1 0 0 0 0. Okay, and for the 65, 0 1 0 0, and then last we have 1. So we do the additional operation. So we have 0 1 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0, and then 1 1 will be 0 1. Okay, if you can see here, okay, 1 here means that it is negative, right? Okay, and then okay, this then okay, if it is 4, represent the sign. Okay, so the answer here is negative side 1, so this is not the right answer. Okay, so this is not the right answer. Okay, so what can we do? Okay, 1 here, okay, 1 here not mean by sign negative. Okay, so in this case we have 1 to 8. Okay, if you still remember, 2 7 is 1 to 8, right? 1 to 8, then we have 1 here. Okay, plus 1 equal to 1 to 9. Okay, so again, okay, 1 here should be not represented by the sign. Okay, so how, okay, the question here how to solve this problem. Okay, so we come up with what we call as the 2's complement. Okay, we will see what is 2 complement problem. Okay, 2 complement technique actually. Okay, on our next slide. Okay, what is 2 complement? Okay, 2 complement actually is plus 1, okay, of 1 complement. Okay, that's mean we need to get the answer for 1 complement first, then plus with 1. Okay, for example that we have here, let's say we have positive 5. Okay, this is equal to 0 1 0 1. Okay, then we make it 1 complement. What is one complement? We change 0 to 1, 1 to 0. Okay, so what we got here, this represent negative 5. Okay, what is 2 complement? Okay, as I mentioned before, we have the answer before. Okay, this 1 complement and then plus 1. Okay, so when we plus 1, so this is what we call as the 2 complements. Okay, so I hope it is clear. And what happened, okay, if overflow happen? What is mean by overflow? Okay, overflow, so you can refer, okay, or you can refer to what I mentioned before. Okay, Just ignore. The answer is just ignore. Okay, we have a question for two complement here. Okay, so we need to calculate 10 plus -4. Okay, they ask you to use two complement methods. Okay, so how can you do this? Okay, this is how can we solve 9. Okay, 9 plus -4. Okay, so we need to change all number first into binary. So for the 9 we have 101, for the 4 0100. Okay, and because we want because -4 is negative, so we just need to change, okay, 0100 into the second complement. Okay, first, okay, before we can have second complement, of course we need to do the first complement first. Okay, so from 0100 it's become 1011. Okay, and then we just carry, okay, 1, okay, we plus with another 1, so it's become 1100. Okay, when 1100, this is what we call as the second complement. Okay, after we get the second complement, what can we do? We just need to do the additional, okay, additional calculation. So what can we have? Okay, we have here 1 0 is become 1, 0 0 0 0 1 1 1 1. Okay, we got here, okay, 110. So can you see 1 here? Okay, this is our overflow. Okay, as we mentioned before, okay, where is it? When overflow happen, just ignore. Okay, just ignore. So what we have, we just get the 0101. Okay, this is equal to 5. Okay, so this is all about the negative sign and positive sign for the number. Okay, so I believe that's all. Okay, that's all for today. I hope also that you can understand what we have learned for today. Thank you for your attention. Thank you for watch this video, YouTube video. Okay, so assalamualaikum warahmatullahi wabarakatuh.